Hello, calculus students. In this problem, we're going to calculate this distance d here, um, given that we have a vector AP and a vector AB, and d is orthogonal or perpendicular to AB. So I'm going to actually do this two ways, but either method is going to require us to compute the vector AP, compute the vector AB, and then calculate their lengths. So let's just do that first. So I'm going to call this vector AP, I'm going to call that U, and I'm going to call this vector AB V, just so I don't have to keep writing AP and AB down every time. Now notice that U is the vector AP, and if I take A as the tail and P is the head, then 0 minus minus 1 gives me a 1, 3 minus minus 1 gives us a 3 plus 1 is 4, and then similarly V is AB, so B is the head, and 5 minus minus 1, because A is the tail, gives us 5 plus 1 is 6. 0 minus minus 1 gives us 0 plus 1, which is 1. So if I then calculate the length of U, that is just 1 squared plus 4 squared is 17, and I take the square root and I get square root of 17. Similarly, the length of V is the square root of 37. All right, I need that information. Now let's do the first method. I redrew the picture here, and I'm going to use the angle between U and V to then do some right triangle trig to figure out what D is. Because once I know theta, and I have the length of U, I could use the sine of theta is D over the length of U to then determine what D is. So let's go ahead and do that. Now I'll use the dot product to determine what the cosine of theta is. So the cosine of theta is of course given by this formula. I'll plug in U and V. So U dotted with V is 6 plus 4, 1 times 6, 4 times 1. Add those together, you get 10. The length of U and the length of V are respectively square root of 17, square root of 37. Multiply that out and I get the square root of 629. I could simplify that. I'm just going to leave that for now. So I have the cosine of theta is 10 over the square root of 629. Now, since D is opposite theta, I'm going to need the sine of theta. So I'm going to compute the answer exactly. So I need to know what the sine of theta is given I have the cosine of theta. Now the way I'm going to do that is I'm going to use the fact that sine squared plus cosine squared gives us 1. I will plug in cosine squared, which will get rid of the square root of 629, so I will get 100 over 629. And then if I subtract that from 1, I'll get 529 over 629 because of the common denominators, and then I'll take a square root and I get that the sine of theta is the square root of 529 over 629. Okay, so now that I have that for the sine of theta, computing D is rather simple. The sine of theta, once again, is D over the length of U. I move the length of U over to the sine of theta, so I get D is equal to the length of U times the sine of theta. The length of U is the square root of 17. The sine of theta is the square root of 529 over 629. I combine those, the 17 goes into 629, turns out 37 times, and I get that the length of D is square root of 529 over 37. That is the answer, so that's the distance P to the line through the points A, B. And there I've used the angle between two vectors to solve the problem. Now I'm going to do it another way. I'm going to use projections to solve the problem. So what I'm going to do is I'm going to take U and I'm going to project it onto V, and I'm going to look at the projection of U onto V here, and we call that U parallel, and it's given by this formula, U dot V over V dot V. But remember, V dot V, that is the length of V squared. So this quantity here is going to be 37. U dot V I already calculated in the previous method is 10. And then V, of course, is given by the vector with components 6, 1. So let's just plug all those values in. So I get 10 over 37 as a scalar. That's the coefficient of the vector with components 6, 1. That's V. I'll just distribute that scalar into each of those terms. And now I have this projection of U onto V. Now knowing that length, look, I have one length of a side of a right triangle, and I have the hypotenuse of that triangle because I already calculated the length of U. So now I just need to use the Pythagorean theorem. And so I have to get the length of u parallel. So the length of u parallel is the this component squared plus this component squared. I get this length here for u parallel, and now I just employ the Pythagorean theorem. So d squared is the um, square root of 17 squared minus this 3700 over 1369 square root squared, and when you square these square roots, of course, you just get the terms inside, and then you get this rather large fraction, and this fraction reduces to 529 over 37. So I get the same result. The takeaway here is the fact that this projection formula is somehow related, right, to the cosine of this angle, and if you go through the derivation of that, you'll see that is the case. But I just wanted to show you two methods to solving this problem. One is where you can get the length of this side by the projection and then computing its length. The other way was to use the cosine and then the cosine of the angle, and then just do some right triangle trig. All right, good luck.